Hi, kids. So today we're going to look at an article from Science, Technology, and the Environment, and it's about the Hubble telescope, which they say is a window into a hidden universe. And this connects with our science learning about light. So here's the Hubble telescope, or a picture that somebody has drawn of the Hubble telescope. Looks like it could be made with watercolors too, and some ink. And I'll read it to you. So when we read an article like this and it has those columns, we read all the way down one of the columns until the end of the page, and then we go back up to the next column and read down that way, and so on. So here we go. Look up, way up, on a clear night. The stars are spectacular, but with the naked eye, you can't see the details of our universe. That's why, in 1610, Italian astronomer Galileo built a telescope. It gave stargazers a clearer view of objects in space. They learned that Saturn had rings, for example, and the Milky Way was not a cloud, but a collection of countless stars. Over the years, telescopes became more sophisticated. So did our understanding of space. However, there's a problem with the ground-based telescopes. The Earth's atmosphere blurs their view of space. The atmosphere is a fluid, chaotic soup of gas and dust. So it blocks certain wavelengths of light from reaching our world. On a positive note, that shifting air makes the stars twinkle. You've probably seen that before. That's because of the air above Earth before you get into space. And they say that that air is moving around with gas and particles. It makes the stars twinkle. What's the solution? Put the telescope in space above the Earth's atmosphere. By 1975, that's before I was born, the European Space Agency and NASA were drafting plans for this space telescope. And in April 1990, the Hubble Space Telescope hitched a ride aboard the Space Shuttle Discovery to low Earth orbit. The school bus size observatory has been circling the globe ever since, 568 kilometers above our heads. It travels at about 27,000 kilometers per hour. It completes one orbit around the whole Earth in 97 minutes. Can you imagine how fast that is, going around the whole Earth in 97 minutes? How Hubble works. Like any telescope, Hubble has a long tube that is open at one end to let light in, or to let in light. As well, it has mirrors to focus the light. Its primary mirror is 2.4 meters across. It needs to be large to collect as much light as possible to see faint objects in space. Celestial objects emit light in a wide variety of wavelengths, from ultraviolet through visible to near infrared. Now, all of this means that stars and things in space give off different kinds of light, all the way from ultraviolet, or you've probably seen light like that, or haven't seen light like that, but that's why we put sunscreen on to protect ourselves from that kind of light. Visible light is all of the colored light that we can see, and infrared, we can't see it, but sometimes we can feel it. It makes heat. Hubble can detect all these wavelengths. The incoming light bounces off the primary mirror to a secondary mirror and eventually to a focal point, Hubble's eye. Scientific instruments turn this light into digital signals that are stored in onboard computers and transmitted to Earth. The signals are then transformed into amazing images. In some cases, Hubble captures a snapshot, like taking a photo or a picture. In others, it captures light coming from thousands of galaxies. This deep field view lets scientists probe the distant universe's mysteries. Hubble's deepest, widest view of the universe took over 250 days of telescope time. It was stitched together from nearly 7,500 individual exposures. So you can imagine over 250 days, this telescope took 7,500 pictures, and then those pictures were sewn together to make a one big picture of the universe. Amazing discoveries. Hubble casts its gaze both near and far. That means it can see near and far. It has revealed new details about the solar system around our sun, but it can also detect faint light from galaxies trillions of kilometers away. Distances in space are vast. Vast means super huge. So it takes the light a long time to reach Hubble. When it snaps a picture of a galaxy 100 million light years away, it shows the galaxy as it looked 100 million years ago. That means it took 100 million years for that light to reach Hubble. Hubble is not only seeing through vast distances, it is seeing far back in time. Wow. This gives excited astronomers, that's people who like exploring stars from Earth, a ringside seat to the evolution of galaxies and stars. We see stars coming to life in the glowing gas of a nebula. We see galaxies collide with other galaxies. Dying stars collapse inward, leaving behind dense neutron stars or black holes. We were talking about black holes this year, and they've discovered even more of them. One that's closer to Earth than the biggest one that they've found so far. Or they expand when stars die, shedding outer layers. Some explode into supernovas. Thanks to Hubble, scientists have pinned down the age of the universe. It is about 13.8 billion years old. They've learned that it has at least 100 billion galaxies. We live in one of those galaxies, the Milky Way galaxy, and on the edge of that galaxy. Can you imagine that there's 99, well, there's so many more. There's so many billions of galaxies. Another revelation? There are thousands of exoplanets orbiting stars in space. Hubble has even analyzed a few and found water vapor on them. The data could help in our search for extraterrestrial life. That means that they found water vapor on on planets that are exoplanets outside of our solar system. Could mean that life has existed there before, or it does now. The dark side. Hubble taught us that black holes exist. Black holes are fascinating. They suck in everything around them, including light. We've learned that supermassive black holes are common in the dense core of galaxies. Then there's dark matter. This odd material radiates no light, yet its gravity holds galaxies and galaxy clusters together. Dark matter is really weird. It's the opposite of matter, which is what everything is made out of. It's pretty mysterious. Perhaps the biggest surprise is dark energy. Scientists once thought that the universe started slowing down after the Big Bang, but Hubble has shown us distant supernovas. From their light, we've learned that distant galaxies are flying away from ours at even higher speeds. That can only mean that a mysterious force works against gravity and contributes to this expansion. Scientists call this anti-gravity force dark energy. Dark energy makes up about 68% of everything in the universe. The objects that we can see, such as galaxies, just 5%. Dark matter accounts for the remaining 27%. So there's way more dark energy and dark matter in the universe than there is actual matter. Things that are really physical, that you can touch, see, smell, taste. That's only the smallest thing in the universe. Did you know NASA is working on 2 new telescopes? The James Webb Space Telescope and the Wide Field Infrared Survey Telescope. The view is fine. Hubble is a window into the enigmas of deep space. Enigmas means mysteries. It has helped redefine our universe. It has answered questions that plagued astronomers for decades. It is revealing strange new mysteries too. It's a handy tool. In 30 years, it has captured more than 1.4 million pictures. It has been upgraded 5 times, and it is still going strong. But no more upgrades are planned. Hubble will eventually crash to Earth. That's what happens to these things. Until then, enjoy the light show.